Here you can see how I've hidden the water solenoids and the water flow sensor. So it's just two cement pots that I glued together, and yeah, you can see it's dripping from the solenoid there, which is for the filling up the pond, and then there's also one other for a micro drip system, and a Gardena filter there to yeah, just get a good pressure to it. So quite simple to hide, I think, and still be able to access it. And here is over by the waterfall where I'm filling up the tap water. So here I'm switching on the water, and as you can see, it comes out here next to the waterfall. And yeah, there need to be some pressure for the solenoids to open, and here it closes again. Of course, the same goes when you have the floating level switch. If it goes too low or too high, it will trigger on and off for the water. But here there's applied a sliding average of 8 samples, so it will take up to half a minute before it actually starts reacting, to not be too trigger happy. Here is the brains for the pond control, and as you can see, here is a Raspberry Pi, and it's a Raspberry Pi 4. This is where you have most of the logic, then the influx database, MQTT gateway, and then there are some Python programs and the web server, etc., so that you use to control the firmwares that you have on Arduinos and such. I used to run this on a Raspberry Pi 3B Model 2, but that turned out to be a bit low on memory. So on a Raspberry Pi 4 is something I really recommend. You don't need to have, I mean, in this case I have a lot of the sensors being physically connected here to the actual controller. But there's also the option like the fish feeder, for example. That one is just going over the Ethernet and going via the MQTT gateway. So that is a possibility too. Otherwise, you will be connecting, for example, the Atlas Scientific sensors that are provided in a separate video that is running on a Tentacle T1 board, a carrier board, and that one you just hook up over USB. So there's one of the USB-A inputs here. And then there's the standard Ethernet, and then some different GX connectors. One for, yeah, maybe I should go through that first. Together here for the pond control is the little prototype board here, which has an Arduino Nano on, and then connected over USB. And it is taking in the water level sensor, so it measures the analog level on the E-tape, Milton E-tape. And then there are two tip 120, which is open and closing the water. So both for controlling the water level, and then the second tip 120 is for opening the micro drip system I have for plants that is in the proximity of the pond. So that's just an extra thing. To be able to open and close these solenoids, there's 12 volt provided. So that's a standard transformer, just hooked up to this GX connector. And then you provide one for the Raspberry Pi power. So the 5 volt that is going in here. Maybe it's not visible, but that's a standard USB C cable that has been just cut to be able to yeah, so the GX connector is used as just to make it easier to connect it here. Then there's also some, like you saw, another USB cable coming in for the Atlas Scientific carrier board. Otherwise, it's pretty, there's not so much logic, even there's a fair amount of cords here that is more to just provide the necessary power supplies for sensors or for the solenoids. but it's quite little logic that is on here. But on the Raspberry Pi, there's then some more Docker images for the different applications that are running here and controlling both this board, but also other sensors. So. But yeah, we'll look more at that in a short while. And yeah, then it's just a transparent casing here for the lid for the casing. As you can see in the bottom here is some plate here, which is just convenient for mounting the Adafruit prototyping board, and then also the Raspberry Pi. Notice also that I've selected it's a very nice form factor for the Arduino Nano for this kind of setup. But there's also one other benefit, because then you don't have to bother about if you have a Nano here, and then for the Tentacle T1 board I have an Arduino Uno. So that will make it easier, because you will not have conflicts. If you have the same type of Arduino, you can end up that you don't know which one you're talking to over USB, because they can have a race during boot, which one will get, they can get the same name otherwise. But if you have different types of Arduinos, then that is prohibited. Then you will get the same name every time. So yeah, I mean, it's a bit by coincidence, but it's always also something that is pretty nice, that you don't have to deal with that and fiddling with the names and knowing which USB device that is connected.
For the programming of the water control, you can see here we have the small service that is running here. It's a small Python program running inside a Docker container. That is just the bridge between the MQTT and the pond control and the Arduino Nano that is running the water control. So this firmware we're going to look a bit more into, and but yeah, I mean it's controlling these, so it works on its own. So even if the controller is gone, it will still be able to keep a level and a flow and turning the water on and off. Which I think is a prerequisite for this to work good. Now to program the water control, we are here at the top of the Poseidon repo, and we can go down to the water control directory, where you will find the serial to MQTT Python program. It's very simple. We will just translate between MQTT and the serial port command. So specific for the firmware, so we skip that. In the firmware catalog, you can source this command file if you want to just build the firmware and upload it. This should work, I think, if you have this connected to your Raspberry Pi and have a platform IO development environment installed on the Raspberry Pi, like we have talked about in previous videos also. If not, feel free to look at those to get some more details. And so we head straight down to the source directory, where we have the main.cpp file. And this program has some small parts here where, I mean, if we just look at the blocks here, we have interrupt handling, that is handling the interrupts for the water flow to just measure the amount of ticks basically. And if we go a bit further down, the main functionality down here is looking at the incoming serial stuff, and just handling that, setting different parameters if you want to turn the water on, off, or the auto leveling, and so on. So it's just a lot of code for the handling the serial commands. So then when we come down to the actual measurements here, so we make sure that we don't measure too often, maybe once every third second, I think the timeout is set to. And we do some calculations for the number of pulses that we have for the flow to do a conversion into liters. And yeah, it's a lot of strange conversions here, and I don't even remember how I came up to this, but it was this is tuned for this flow sensor so that I have. So I think you need to do the same to get, you will probably get decent values from this, but I think you should tune it and just switch the water on and measure it in a bucket to see how well that matches, and add some other factors to it. Then we read the analog value from the voltage divider, and this depends on if you have it configured to be a CUS liquid level sensor or if you use the E-tape. And it's really just a conversion from the analog read value into to be into the percentage level instead. And then there are some sliding average applied to this. So 8 elements, you need to have 8 elements in this array here, and then there's an average calculation done over that before taking any decisions. And if the water level is the mode is set to be automatic, then the water will be turned on if it gets too low for this sliding average. And then there's some feedback being sent back also with the state of the sensors and if we're filling up the flow, etc. The only thing that you need to configure is really to decide which kind of sensors you want to have, if it's either the CUS one or the E-tape. And then it's also a matter of where you want to have your value at. So I mean, it depends on so this is expressed in percentage then. And in this example, I've set just the low value to be 88% and the high 89%. But there are really this is a CUS liquid level sensor, so there is actually no values between that are in this range. So it goes between 91% and then it goes down to 86%. So this is just values that are just, it will toggle between 86% and 91% because that is the kind of accuracy that you get in from the CUS liquid level sensor. So that's why it's chosen like that. But yeah, this works really great, I think. That's basically it. And then there are some code for the level detection also. If it goes up maybe above 95% or so, I've set that to automatically switch off the auto leveling since there's something weird then. So yeah, that can be added more if needed, but this is working good, I think.